My name is Simon. I'm working with the system validation team. So here doing system validation for NSO and for the new workflow product. Today I will talk about NSO observability from a system validation view. So I will talk a little bit about how we use the observability when we do system validation testing for NSO. Just to, if you missed the talk about the observability exporter that Christian had yesterday, then I think you should look at that. That was a good talk. I think the YouTube stream will be available later. And also, Ulrich had a talk earlier today about the full stack monitoring. That one is also good, and it's I will not go as much into details as they did. So if you are looking for details about that, look at their talks. So what am I going to talk about? I'm going to talk about validating performance. And that is one of our tasks, is to validate that the NSO is that there are no performance degradations, that the performance is not changed to the worse. So I will talk a little bit about how we are testing. I will talk about an example that we will go through, where we have a 3-layer LSA test case. And then we will go through tools that are used to monitor and measure how the NSO performs. So, first of all, test on small changes. We are testing when NSO changes. The services that we use, they are constant. So we in the test pipeline, we have tests for each PR that is made, and we have tests every 3 times a day. There is a build, and that also has a couple of tests. And then when that build is finished, then we start our tests. The reason we start our test later is because our tests takes quite a lot of time. We try to finish our tests within 2 hours, but we use 10 test nodes. So we have, if we put the test in sequence, it would be more than 10 hours of tests. So trunk builds 3 times a day, and all other active branches is tested once a day with our tests. And what we have seen is that changes are easier to see in graphs than in tables. So just it's easier if you have all the test results graphed compared to looking at them in a list. And what we do is that we store all the tests. We use Grafana to view the test data, and we store all our test data in InfluxDB. So that makes it easy for us to find historic data about the tests. And it's easy for us also to look at old tests, since all the data is stored in InfluxDB. We use the observability exporter, the Prometheus node exporter, NSO process monitor, and the metric exporter. They are used to collect the data, and the data is stored in both InfluxDB and Prometheus. So we will go through one of the test examples we have. It is a little bit difficult to test the complete NSO. since we have a lot of the services can vary a lot, and yeah, it's impossible to test everything. So what we are focusing on when it comes to system validation is customer use cases, because we think that's as close as yeah, we are trying to test what matters, and that is customer use cases. And then we are also doing some tests for features which requires more time or more resources. And the example I will go through now is we have a test where we test a 3-layer LSA system. We have a top node with which is called E2E node, and then we have CFS node and RFS node. We use NetSim devices that we write the configuration to, and on each level we have a nano service, and we also use commit queues. So what we are trying to do with this service is we write configuration to the E2E node, and that service eventually creates configuration on the NetSim nodes. So we wanted to test nano services. It could be done with a fast map service as well, but it was good for our tests to test on other services. So that is the reason.
Because to gain the performance and throughput improvements on the NSO, is it a must to have nano services, or we can use the fast map services as well?
I think that the benefit of using nano services is that you can scale. In this example, you see that we have 4 RFS nodes handling 1/4 of the devices each. So I think that is one reason of using nano services, that you don't have to handle all those devices on one node. Yeah, so this is the test setup that we have. It's a lot of nodes, and we run it on Docker in our tests. On top we have the test node, which is adding or creating services, and on the bottom we have the devices. And yeah, in this case there are 7 NSO nodes, but we are also testing HA, so then it's 14 NSO nodes, and soon we'll be testing Raft HA, and then it will be 21. So it's a larger test that we are doing. So how do this nano service look like? This is not a detailed view of it, but this is the states that we have in our nano service. We have an init state, and then we have an add config state. In the add config state, we use a template to add config to the underlying services. And then the ready state is reached when all underlying services has reached ready state. And how do we know that? We do that by listening to plan state change notifications. So this is the service on the top and the mid node, and the service on the lower node is quite similar. The difference is that we say that we reach ready state when the service commit queue is empty on the lower node. That is when we have configured the device. So looking at this, this is what it will look like. We will add configuration via RESTconf, and then we will get the reply for that. And the E2E node will, via the template, add configuration to the CFS node, and then to the RFS node, and then device config will be added to the device. And now, when the device config has been set and the commit queue is empty, then the RFS service on the RFS node will reach ready state. So that one will be reach then plan state change notification will be sent to the CFS, and the CFS will send the plan state notification up. So the test node will get the information that the service has reached ready state. So the test node behavior, what is happening on the test node? Well, the services are added one by one using RESTconf. It is possible. We have other tests where we use the CLI and validate the response time for the CLI. But when we have added the services one by one, we are adding them in parallel. 25 services at the time, or we do add 25 services and then we wait until we get the plan state change notification that the service is up, and then we add the next one.
Are these services included in Python or Java?
It's Python. So, looking at the test results, what can be measured and validated? First of all, we have the measurement on the northbound interface, and I think those are the easiest. That is just measuring how long time it takes from in our test case the first RESTconf call to we get the last plan state change notification. And then we can measure the service create time for all the services. We can also measure the time it takes for each service to finish. And then we can have the same for service delete. It is also possible to use the observability data from Observability Exporter. And that what we can do there is that we can validate spans. And so we have both the northbound, what we can measure from externally, and then we can also, via the Observability Exporter, look at internal measurements. So this is the result we get for example, for this time all services ready. This is measurements we get when we have tested, I think it's 100 services, and we get and we measure the time from the first, how long time it takes to set up all services. And here you can see the red line is trunk, so that is what will be 6.2 now. Then we have 6.1, and the blue one is 6.0. And then we have the older, or the 5.7 and 5.8. I think that 5.6 is still active, an active branch, but it's we are not using, or it's not supporting 3-layer LSA, so that's the reason why it's not included here. But here we can see the result, and if there are any changes between different builds, we see that, and we can also see the difference between releases. So using the observability exporter, What we need to do when we want to validate things based on the observability exporter is, first of all, having it enabled. In our test cases, we always have the observability exporter enabled, and we store all the information from that, so it's possible to look at old data as well. And we store all the data for 6 months. So we can go back and look at these builds for 6-month-old history. All data is stored in InfluxDB, and for the observability, sometimes we need to do some processing to after we have run the tests, and that is mainly to be able to easier find the data that we are interested in when we do queries later. So these are 2 examples of data from the observability exporter. We have calculating southbound diff, and what we have done here is that we are doing a lot of sync froms, and then we calculate the mean for all of the sync froms within that test, and then it's easy to compare it to older tests. And then there's also a validate. So I think it's very easy, since we have everything in Influx. It's easy to do the validation on things in that we get from Observability Exporter as well. Okay, so that's those 2 things. What more is interesting to understand what's happening? Well, CPU and memory usage is one thing. We are using Prometheus Node Exporter and NSO Process Monitor. Prometheus Node Exporter, you get node information. And this is kind of what you get from the Node Exporter. You can see if we're running out of memory on the node, or if the CPU is overloaded, or for example disk space. So it's more a check that the node is okay. But you can't really see anything about what's happening inside the NSO. So for that we use the NSO Process Monitor. And here you can get detailed information about both CPU and memory per process, and I think that is very useful. We get the information. The NSO Process Monitor is a package. It's part of the full stack monitor thing that Ulrich talked about, and I will show you a link to that in the end. We are using PSUtil to get the information, and it exports data both to Prometheus or Influx. And then you get pretty good information about how much memory each process is using. I think the orange on the top, that is the NCS, the main process, and then you have the Java VM, and then some other processes. So I think this is pretty good. It gives you some information, and we also have this. This is the CPU usage. We add these event markers in Grafana to mark when we are doing things. And the first span there, that's the create, and then we have the delete here. So this is the test case I showed you earlier with nano services, and this is from the CFS node. And what you can see there is we are trying to push as many services as possible, but the CFS node is quite loaded in the beginning, but then in the end it idles. So why does that happen? So we need some more information. What we also can use from 6.0, there is a metric exporter. You get everything. That's a lot of counters and gauges. So what the metric exporter does is it takes all those and exports it either to Prometheus or InfluxDB or both. And if you want your own counters, you can just add them under metric. You can augment metric, and then you can add your own counters, and it will be exported as well. So looking at what we get from the NSO metric exporter, we can look at the commit queues for the same. It's the same example. And then we see that the blue one, that is the top node. And then we see the green one is CFS1. That was the one that we saw the CPU usage from. And then the yellow one, that's CFS2. So what does this mean? I think it means that we are doing something a little bit wrong. From the test node, when we add services, we add them first. We add 100 services. We add 25 services on RFS1, and then we add 25 services on 2, and then on 3 and 4. So we are adding them we are not balancing the load in this. And I think it's this graph is pretty good to show that. And it's difficult to see if you only have numbers for it. So this is a good way of showing that. So what can we do about that? If I try to add them one by one in a round robin fashion, what will happen then? So when I do that, I can measure the service create times, and I see that it goes down from 58 seconds to 44 seconds. And looking at the commit queues in this case, it's a completely different picture. Here the load is evenly distributed on both the CFSs and the RFSs. And this also shows in this CPU graph, where we have we are using more of the create span. So this is the link to the monitoring stack. I think that was it. If you have any questions, please ask them. Otherwise, I'm finished well ahead of time, and I hope you don't mind about that.
Maybe a bit of unrelated question. So
Yep.
you also talked a bit about metrics. So there is this metrics exporter. What do you think is like the most important metric, or like 3 or 4? We should, if we're starting with this kind of monitoring stack, we should look at this.
I think it's difficult to say which is most important, but I think that if you are planning to start looking at the metrics, I think you should export everything. At least you have the sysadmin metrics. Those are safe to export everything. But if you can also enable, I think it's develop and debug, and those might have an impact on services or service create times and stuff like that.
In your monitoring, if you launch another process, another Python process, are you picking it up also?
Yes, yes, yes. So it's all processes that are started by NSO. So if you add a package, those processes will be seen in the process monitor.
So if I do it via an action and then run a sub-process in the Python code and I do a run,
Yes, I think so. I'm a bit. Eventually, it will. I'm not sure you will get it exactly when you create it. I think you periodically check if there are any new processes. Yep.
Does this spec have any NSO version requirements?
The metric framework is from 6.0. I think the process monitor could be used from, I think we have it enabled from 5.5. And the observability exporter, I think you should use the latest. You should use the latest, but I think that it is possible to run. I'm not sure about that.
Rust worked with 5.7 before, so
Yeah, yeah.
I'm not sure if it's compatible with 30.
So the latest one is compatible with the former NSOs. This is what Christian said yesterday.
Yeah.
You have to rebuild it yourself.
Okay, so more questions? So far so good?
Yeah.
Okay, well, before you go, just one reminder. Remember that at 5 on the arena, you can go to meet the engineer. It's going to be from 5 to 6 on the stage 1, 2, 3, and 4, and also on the Space Club 5 and 6. And also there are some partner demo tables. So, thank you everybody for joining us today. We'll see you tomorrow.
Thank you.